Welcome, everyone. My name is Randall Rollinson. I'd like to welcome you to the AI Community of Interest for Strategy Professionals. I'm president of LBL Strategies and co-sponsor of the AI Community of Interest. I and other co-sponsors, you'll get to know Mark if you're here last time. You met him from Transformative and the Army Strategists Association. We all welcome you today. We're really pleased that you've taken time to attend the second of our monthly AI and strategy webinars. These webinars are always free and anyone is welcome. The goal that we have that we discussed in the beginning is to establish a monthly forum where we learn from each other, where we learn together about the technical revolution unfolding before us. A special interest to our team is to gain a shared understanding of the impacts, the benefits, and barriers that must be overcome to take advantage of this new reality. Now, I'd like to introduce you to Robin Champ. She's our VP of Strategic Foresight at LBL Strategies and our moderator today. Take it away, Robin.
Thanks, Randy. The presentation will run for around 45 minutes, followed by a 15-minute Q&A session. This session is being recorded, but the recording will be turned off before the Q&A session begins. We will make an announcement when recording stops so that you may feel comfortable asking questions in a non-attributional environment. Please enter your questions in the chat at any time, and I will ask them on your behalf at the end of the presentation. Or feel free to raise your hand at the end of the presentation and engage Lieutenant Colonel Schieman directly. So today, I'm very excited to introduce Lieutenant Colonel Kevin Schieman, who will talk to us about generative artificial intelligence. Kevin is Lieutenant Colonel in the U.S. Army and an Academy Professor in the Department of English and Philosophy at the United States Military Academy at West Point. His operational service includes 24 months deployed in support of Operation Iraqi Freedom and nearly 1,000 combat flight hours in the UH-60 Black Hawk. His awards and decorations include the Bronze Star, the Air Medal, and the Senior Army Aviator Badge. He graduated from the United States Military Academy in 2003 with a BS in Mechanical Engineering. His postgraduate education includes an MA in Philosophy from Georgetown University and an MA and a PhD in Philosophy from the University of Notre Dame. His philosophical interests include the ethics and philosophy of technology, philosophy of mind, and cognitive science. So with that, please welcome Lieutenant Colonel Schieman.
Thanks, Robin, for the lovely introduction, and thanks, Randall, for letting me talk to your monthly webinar. It's a great opportunity for me to kind of share some of the things that I've been researching in a slightly different context. I did spend about 3 years as an FA-59 before I transitioned here to working at West Point. And so I'm at least familiar with some of the sorts of problems that you guys might be trying to understand AI with an eye towards trying to solve and trying to work with. So thanks to everyone for being here and taking the time today. What I want to do today is my background, as Robin said, is as an academic philosopher. And so I want to offer a bit of a primer on generative AI. And I think that this kind of talk is stemmed naturally from some of the work that I've done here at West Point, trying to understand these technologies maybe in a slightly different context. Obviously, generative AI has had a significant impact on higher education. So one thing that we've been trying to understand is what is the technology capable of? How is it going to manifest itself in the classroom in negative ways, right? Is there an opportunity here for cheating or for passing off computer generated work as your own? Certainly that's a concern, but also for understanding how we might use the technology to enrich the classroom, and both of those things, understanding how to avoid the harms of generative AI, and also understanding how to leverage them to create more technically literate graduates, because these technologies I presume are going to continue to proliferate. They're not going away. So the question is, we have to understand the technology at least sufficiently well to be able to make policy and to be able to make decisions about where there are opportunities for its use in the classroom. And so what I've really tried to do is I've tried to understand generative AI and other approaches to AI, other types of AI, maybe not in the technical detail of somebody that's trying to build their own networks, but at least well enough to ask informed questions about the ethical use of the technology. And so what I intend to do here today is really, I'm going to start out by just giving some definitional stuff. I don't want to presume that anybody is intimately familiar with generative AI besides what you might read in the news, because obviously it's been a part of the daily news cycle for about the last year, and I'll talk about that a little bit. To give you a brief history, most of that's going to be focused on the last 12 months because things have moved very quickly since OpenAI released ChatGPT in November of last year. So we'll talk about that. I want to talk a little bit about the technologies that are driving generative AI, and really, I mean that in the context of the software more than the hardware, though obviously there's a relationship between the two. I'll speak a little bit about the present limits of the technology, but really what I want to build towards is some tips for using generative AI. And so the idea is for somebody that is not working in an AI field, but is working in a field that's affected by AI, how might we approach these technologies in ways that can lead to better outcomes and help us to build proficiency with the technologies? So it seems like a good place to start. Just what is generative AI? So generative AI tends to be deep learning models. So models that are large, a lot of machine learning parameters that are programmed. They learn from data and they can generate high quality text, images, and other kinds of content based on the data that they're trained on. So we'll talk about some of the things that can include. What's really created most of the churn about this in the last year or so is that we've actually had generative AI that was able to generate natural language text in ways that were, in some cases, indistinguishable from human produced text. And we can talk about how it did that. But that was really for a long time a major barrier. Natural language processing, like visual image recognition, computer vision, were really hard problems to solve through AI. And what we've seen in the last year is this sudden leap ahead in the technology where you're not just producing what seems to be human generated text, but sometimes rather large quantities of it. The latest version of OpenAI's ChatGPT software, based on their GPT-4 model, is capable of producing large strings of text, like chapter length text. And so generative AI is just AI that's focused on producing content of some sort or another. So what does that include? Well, I'll include a version of a text generation application that I've shared in the past, but this article was actually written by generative AI. I'll give everybody a moment to read that. I want to say that this was maybe January or February of this year. I produced that text by prompting ChatGPT to write a newspaper article that imagined a world in which the Corps of Cadets had been replaced, or DoD had undertaken a plan to replace cadets with AI as during the initial hype surrounding ChatGPT. And it produced what I think is, I mean, it even what I like about this the most is it actually creates a quote from the dean. I think the first version didn't include that. I asked it to quote the dean and it made up the quote. I just love talking to ChatGPT. It's like having a never-ending conversation with a knowledgeable friend. But so the idea is it's capable of producing plausible text. I think it actually produced the caption on the photo, if I'm remembering correctly, too. So this is the sort of thing it can do. It's capable of producing poetry. Another capability a lot of these text generation softwares have you're actually able to kind of shape it. You can make it sound like a New York Times article. It's able to kind of adjust the style based on prompting. So if I wanted to, I could produce another one of these and tell it to make it sound like it had been written by Shakespeare. And it's generally able, provided there's something in its training data, it's able to kind of localize like text that's written by Shakespeare. It would be able to produce something that sounds like it was written in Shakespearean verse. So pretty versatile in its ability to produce text. So it's also able to, there are also other networks, other softwares are able to do text to image application. So what you see there are three computer generated images that were produced by a generative AI system called Midjourney AI. Midjourney AI is, you do have to have a paid subscription to use it. These were all publicly, I just got them via Google. But essentially you're prompting it with text and it's producing images, and you can refine them as you see fit. Moving from left to right, the prompt that generated the photo on the left was pink Porsche 911 at Lake Seelowsee in Switzerland, surrounded by plants and colorful photos. Fujifilm Velvia 50. So you can even specify the kinds of cameras or photos, and in many cases, the AI is able to adjust the image to produce something that actually appears to have been generated in the way that you wanted it to. The one in the center, the prompt was 1960s style street photo of a crowd of young women standing on a sailboat, silk and linen dresses, pearl necklaces, sunset over the ocean, Afka Vista 200. I assume that's a camera. It says hyper realistic. So it's trying to produce something that appears to be a natural photo, an actual image. Though I will tell you, if you look carefully at these photos, you can often find quirks, like sort of Easter eggs, things that indicate that they weren't in fact generated naturally with a camera. But nevertheless, and the last one is a tabby cat dressing up as a warrior movie scene, wide angle on top of a mountain, Fujifilm photography, sunset lighting. So the point is that even just by telling it exactly what you're looking for, it'll generate the image, and in many cases, fairly lifelike, if not completely lifelike images. There's also text to video applications. I haven't included one here. The website Canva actually pretty recently rolled out an AI tool that's supposed to help you develop text to video for Canva's presentation application. Use it to generate PowerPoint or PDFs, brochures, those sorts of things. So they actually have one that's supposed to be pretty easy to use, but I have to admit I haven't played with it yet. I do enjoy kind of playing with these web-based applications, but it's a matter of keeping up with them because they seem to be rolling out more quickly than I have free time to play with them. So that's on my list to do is get to Canva. All right, so I want to talk briefly about the history, how this has kind of unfolded over the last year. I mean, I will tell you that working in academic philosophy, it's interesting. I'd given a version of a talk like this for Robin maybe about 6 months ago, and it's incredible how much has changed in those 6 months, right? So if you're writing about Kant's ethics, I mean, I could probably use the same presentation over on and off again throughout an entire career because the scholarship doesn't change that quickly. Well, that's not true, obviously, in the field of generative AI, where new networks are coming out every day and companies are releasing updates. So when did this all start? Well, November 30th of last year, 2022, a company called OpenAI, who's been in the news a lot lately for turnover in their leadership, their CEO, they publicly launched an application called ChatGPT, and within a month, it had become so popular, and it was so successful, and was such a leap ahead in the publicly available technology that they became the largest growing software company in the world. I'm not sure how long that trend continued, but it exploded, and the company blew up. I will say that they had a model called GPT-3, and that had been available for 6 or 8 months before they publicly released ChatGPT. And in the fall of 2022, I was actually teaching a tech ethics class, and I had decided that I wanted to kind of play with this technology in the classroom. And I had started playing with GPT-3. You had to buy tokens for it. It wasn't as easy to use as ChatGPT, but I decided that with the free tokens you got for signing up, I was going to have all my cadets, we're going to do like a Turing test. I was going to have them write a paragraph, and I was going to have them use GPT-3 to write a paragraph, and I was going to go into class. We're going to read both of them, and I wanted to see if we could distinguish like which one was computer generated and which one was generated by the cadet. And I kind of reached a point as I started playing with this. I realized that honestly, the technology reached a point where it was actually really hard to tell, and I was kind of concerned. I was like, man, this might be a little bit out in front of the institution if I'm showing this to cadets that aren't otherwise aware of it. Well, I decided not to do it, and within a week, OpenAI made this publicly available, and it blew up in the news, and all the cadets within 2 months had found out about it, and they were all playing with it. So this was just over a year ago, right? A year and a week that ChatGPT released this program, and probably January was about where it kind of reached a critical mass where it was so popular that you actually couldn't get online on the beta in many cases because the demand outstripped their available their ability to kind of to manage users. So move on from that. They had announced that they were working on an upgrade to GPT 3.5. Essentially, it was an intermediate version of this that they had produced to create the Chat GPT version that everybody's familiar with. They said by summer of 23, they had anticipated June or July they were going to release an update. Well, they released that in March. That's how quickly this moved and things changed. I was actually in the process of hosting a faculty colloquium where we talked to faculty about the technology and large language models. And I think we had done one of them. And then there was this massive release of a new software. And it wasn't a small change. It wasn't like they just made it larger. It wasn't like they just taken the same thing and made it a little bit better. It was a massive upgrade. And one of the things that I'm going to do later on, because I think it's indicative of the direction that the technology has moved in the last year, I'm going to talk about what GPT 3.5 was, the first version of ChatGPT, the strictly language model, and what GPT-4 was, this model that came out only 4 months after they'd made the public version of ChatGPT available. And so I'll talk about that a little bit. The big difference here, and there's actually quite a few differences, but the one that's most noticeable is GPT-4 wasn't just about text to text. So ChatGPT, I could type in a prompt, it would produce text. GPT-4 would caption images, so you could put in an image and tell it to caption it. It would generate images. It would do all of these things that ChatGPT just did not have the capacity to do. So it was a significant expansion of what this kind of text generation thread was capable of doing and the modes of analysis it was capable of engaging in. So in a market like the tech market, unsurprisingly, Google had been working on its own chatbot for some time. They released it 3 days later, March 17th, called Bard AI. And so that was based on their own large language models, something called Lambda, Palm, and Gemini, which I'll get to in just a moment. Lambda, for those of you guys that follow the news, you might be familiar with. It was actually the text generation application that an engineer named Blake Lemoine made national news. He claimed that he had been working and testing Lambda, and he decided that he thought that the software was sentient, that it had become self-aware. And there was a very public dispute where Google wound up actually terminating his employment. And so if you're interested, it's Blake Lemoine, Lemoine. It's kind of an interesting story. But he had decided that the bot was so proficient and it was able to describe its own experiences in a way that he thought it wasn't just a software anymore, that it achieved something more than that. So all of this in the last year. And then most recently, literally yesterday, Google announced a forthcoming release of what a model they're calling Gemini, which they hope will compete more successfully with ChatGPT. When they released Bard AI, it kind of fell on deaf ears, I suppose, to some extent. People were using ChatGPT, they were comfortable using ChatGPT, and Bard AI never really took off. So Gemini is probably a more competitive model compared to what GPT-4 is. Multimodal processing and just leap ahead in the technology. So what we've seen just in the last year is not only massive advancement in what these kinds of networks are capable of doing. But we've also seen a proliferation. There are multiple companies that are producing products in this space and that are competing with one another for market share, for our attention, for our use. All right. So all that said, I want to give just a little bit of historical context. So one thing that I think can lead us to mischaracterize AI is the sense that we've reached a point where it's just going to take off, right? Like that the hype, AI is finally going to live up to the hype that it really generated back in the 1950s when we started studying the idea of intelligent machines, of trying to systematize research efforts to produce machines that were capable of doing things that to that point only humans could do, engaging in these incredibly sophisticated cognitive tasks. Well, there's also a sense in which if you study the history of AI, and as a philosopher named Nick Bostrom does, he's pointed out that the history of AI is really a sort of process of alternating between great hope for the technology and despair. So we have these hype cycles. Technology demonstrates some capacity for solving whatever kind of problem. We get massive investment, and then the technology hits a wall. There's some limitation that as constituted, the technology can't overcome. And generally what that leads to is a period of disinvestment from the technology, right? People stop investing in it, and we get into what are frequently called AI winters. And so I only say that not because I think we're necessarily headed for the limits of this method of generating artificial intelligence. Maybe we are finally at the point where the explosive growth will continue. But I think it's important to point out that as much change and as much growth as we've seen over the last year, it's kind of like predicting financial markets. There are ups and downs, and as you're riding, a stock up, it feels like it's just going to continue forever, but we know that's generally not how it works. So I just like to point out that while there's been incredible growth and there's reason for great optimism, as you see different methods in artificial intelligence coming together to try and create leap ahead technologies, it is also dangerous to assume that the rate of growth we've seen over the last year will continue, right? We may have an opportunity to catch up, and maybe there's even stagnation in the technology before it takes the next step forward. We just don't know, and I think it's an important historical context to kind of point that out as we talk about the technologies. All right, so I want to talk a little bit about the technology itself. So a lot of the advances in the technology we've seen over the last year have been driven by an artificial neural network architecture called a transformer. So when we talk about ChatGPT, GPT stands for Generative Pre-trained Transformer. And transformer is a way of organizing the nodes within a neural network. So it's a way of changing the mathematics that are going on within the network to produce certain sorts of qualities, right? So every arrangement, every mathematical system is capable of modeling some things and presumably not others. But what's really great about transformers is they excel in natural language applications like translation and text generation. So it traces back to a paper, I want to say 2017 or 2018, where these networks were identified as a really effective architecture for doing language translation. So if you want to translate English to Chinese or Chinese to English, they were really good at doing that. They demonstrated incredible proficiency. So the first applications of transformers were actually in language generation. And only more recently have we been able to scale them in such a way that we found proficiency in predictive text generation, right? So what you see at the bottom of the screen here is kind of how these networks are trained. So what you actually start out with is just a large corpus of unlabeled text. And I'll show you in a bit for a company like OpenAI, that's just a lot of human writing that's captured on the internet in different kinds of contexts and forums. But you start out with that, and essentially training the network is a process of masking certain parts of the text and training the network to predict what word would occur there, right? And so what a large language model is doing is it is in fact modeling the way that people use language given the data provided to it. So you might think about this in terms of a really sophisticated version of the predictive text feature on your phone. Presumably it's a bit more sophisticated because it works a lot better than the predictive text feature on our phones, but it's the same kind of idea. It's essentially modeling stochastically how people use language. So given certain chains of text, what kinds of utterances are likely to follow from that? And that's the basic idea that a transformer is using to develop a model of language, and that a program like ChatGPT is using to engage in text generation. And we'll talk a little bit more about how this might interact with networks that like convolutional neural networks that capture images or try to represent images. But the key here is, as a linguistic model, it's really engaged in studying a lot of text and saying, when people use words A, B, and C, words like CD, whatever, tend to follow from that. But the special thing about transformers, the thing that seems to make them so good, is that they're incredibly effective at capturing context. So transformers use a process that's called self-attention to achieve contextualization. Now, what do I mean by that? Well, context is incredibly important to natural language use. And so we kind of recognize this intuitively, in that the meaning of a word depends not just on a particular word, but the words around it in a sentence. So for example, if I were to use the word bank in a sentence, that could mean a bunch of different things. It could mean the place that I keep my money. It could mean a way of bouncing a basketball off the backboard into the net. It could mean the edge of a river or a stream. It could mean a place where data is aggregated, right? Like a data bank. And so how do we see that word in different contexts and understand how it's in fact being used, what the meaning is in a particular utterance? Well, it doesn't just depend upon the token that says bank. It depends on the other words that happen to occur around it. And what a transformer does is it learns to recognize which words in a sentence are more or less relevant to determining which usage of a word like bank or bark in the picture are relevant in a given case. Like, how are people actually using the language? So what they learn to do is transformers learn to weight certain combinations of words in encoding prompts and querying the training language, so they can understand, in a very, very weak sense of understand, how the language is being used and where to search in their training space, and how to how the language is actually being employed. And so that's really the difference, this idea of self-attention, looking within a sentence, not just looking at the sentence as a whole, but figuring out which words in that sentence are most important to not just understanding what's being asked in some sense, but also how to respond to it. And we do this very, very, very well naturally. We learn when we're reading a sentence what to pay attention to and what not to pay attention to. In fact, like, speed reading is all about these kinds of making explicit these kinds of tricks. But the transformer mathematically is really good at representing this. And so if you make these transformers big enough, then they can capture a whole bunch of patterns, and these sort of exquisite language abilities seem to emerge. So hopefully that was clear, and I can try and handle any questions if that's not sufficiently clear later on. I don't want to get bogged down on the details, but that's what's special about these transformers, and it's why we've seen this emergence. Really, two things. One is this particular architecture, but the other thing is scale, and I'll talk about that in just a minute. So if we talk about the original ChatGPT, what I call GPT 3.5, the OG chatbot, it was a massively large network. It had 175 billion different machine parameters. And so what do I mean by a machine learning parameter? That's essentially a single variable that you can adjust within the trained network so that it's able to take some set of inputs, a prompt, and produce an appropriate output. So it's just a massive number of patterns that this thing is learning in order to make predictions about what's an appropriate response given the thing that you've asked of it and its training data, right? So you have this massive network, massive number of parameters, but but it was also trained on a massive corpus of data. So roughly 570 gigabytes, and I'll talk about exactly where that came from. I should caveat this by saying, despite the company name, OpenAI has become much more proprietary over the last year and a half. They don't share all of the information about their networks. So some of the things that I will tell you about what people think GPT-4 is, or how big GPT 3.5 was, some things OpenAI has talked about, some things they haven't. And so some of these are sort of reverse engineering, smart people that build these networks, trying to figure out how ChatGPT reverse engineer how OpenAI has been able to build these networks. But as a result of this massive network, this massive transformer, and this massive corpus of data, it can essentially, a trained network can generate human-like text, so poems, stories, even computer code. And I should point out, one of the limitations we'll talk about here is that the network it's amoral, right? So if a lesson that Microsoft learned back in 2016, they actually used a chat bot and they put it on Twitter. It was called Tay Twitter bot, and they had to shut it down within a day. It was very publicly embarrassing for the company because the network actually, I mean, we've all been on the internet. We know it can, in places, be a bit of a cesspool, right? So if it was learning to talk how people talk on Twitter, that's exactly how it started tweeting, and it started like racist and misogynistic tweets like within 24 hours. It was a real disaster for Microsoft. If you're interested, Tay Twitter bot, TAY, look it up. So what OpenAI has done is they've actually used a human supervised reinforcement learning paradigm on the backside. So what that means is they have human beings reviewing the prompts that it gets and the responses it makes and filtering them. So it's actually, it'll say like, hey, that was a bad answer because you used inappropriate language, or that was a good answer because you didn't, respond to this inappropriate prompt. So the language model itself is being filtered through a human reinforced paradigm to prevent it from responding in inappropriate ways. So in a sense, it is kind of learning to filter its text, but only by virtue of a massive investment of human resources on the backside. All right. So when I talk about scaling, I really like this particular slide, because what it shows is how significantly the size of these networks has increased since 2017, when the Transformer paper was published and people started using these for language applications, right? So on the left-hand side, you have the number of parameters, the number of variables that the network included in millions of parameters. And this cuts off in like 2019, 2020. Maybe I should find one of these that actually includes more recent networks. But what I've identified here on the left-hand side is the size of GPT 3.5, that how big that is, that 175 billion parameters in March of 22, and how much bigger than that GPT-4 was in March of 23. So what you've seen is this massive exponential growth in the size of the models. So it's not just driven by the transformer, it's also driven by the computing power that's necessary to actually train and then employ a model like this. So you just see this massive exponential growth. In fact, I mean, if you did add GPT-4 to this scale, it would be so far above this. It's orders of magnitude bigger than previous models, and that's the direction that the technology has gone really in the last several years. But really seeing the benefits of that exponential growth over the last year, where we've seen these leap aheads in the capability of the technology. So I do want to share this just for sourcing purposes, and I should point out that OpenAI has been criticized for violating all sorts of copyright and human use rules. So essentially appropriating other people's work. This is publicly available. They've said that they got training data for GPT 3.5, that 570 gigabytes, from Google, from the New York Times, from Wikipedia, WordPress. So they really use all kinds of different writing, right? They use blogs, they used scholarly sources, they used publicly available journalism, even GitHub, right? One of the things that these networks are actually really good for, and I talked to colleagues in other departments that do coding, so statisticians and computer scientists. One of the things that they really benefit from is you can actually get it to do coding for you. You can get it to debug code, and it's really effective at doing that because that's essentially a language generation task. So you can take something like a plain language algorithm, and you can ask it to translate that into code, and then you can actually run that code. And it's actually for my colleagues that work in fields that require coding. They'll talk about how much time it saved them. So it's not just text generation in the traditional sense, and so OpenAI is kind of developed and trained their model with that particular type of language use in mind, which I think is really interesting. But again, they have been criticized and there's actually open lawsuits against OpenAI for using material that people claim they had a claim to. It's a really interesting philosophical and legal question that I won't engage in here. But I think the important thing is just recognize the scope of how they're pulling data in. And remember that number, 570 gigabytes, because GPT-4, which I'm going to talk about on the next slide, is significantly bigger, and it draws from significantly more data. So what do we know about GPT-4? Well, one thing I know is that it's not just a transformer, right? So some of the things that it's capable of doing, a transformer alone wouldn't be capable of doing. So most people in the industry think that it's a mixture of experts architecture. So the best way to think about that is it's a system of systems. So you have a language model that's managing the inputs, but then there's a system that engages in one kind of computation. Maybe it's a convolutional neural network that does visual image identification, and maybe another one actually has access to Google or the internet, so it can update its data. It could query the internet. I know that they were working with a company that sort of built a symbolic processing language to overcome some of the other limitations that people identified with the initial version of OpenAI, right? It wasn't able to engage in symbolic reasoning, so it would get all kinds of things wrong. You'd ask it, how far apart two cities were, and it would very confidently give you the wrong answer. Or if you asked it to do math, it would very confidently give you the wrong answer. So it appears that what they've done is they've developed a system of systems. And I've heard people estimate that it's anywhere between 14 and 17 different machine learning networks that are sort of organized under a common language model, under a transformer that they use to query and interact and produce outputs from all of those things. So the key here is you're talking about massively increasing complexity as you have not just large networks, but you have different kinds of networks interacting with one another in a sort of dynamic fashion. So I talked about the size of the network, how much bigger they think GPT-4 is. As I understand it, for a while, OpenAI wouldn't say how large or how small GPT-4 was. I believe it was an unintended leak, but right now people think it's about 1.8 trillion machine learning parameters. So by comparison, this network is like 10 times bigger than GPT-3.5, than the original ChatGPT. And I said that number before in terms of data dependence, like how much data these things need to learn and be effective in producing language. I said that the initial ChatGPT, 175 billion machine learning parameters trained on 570 gigabytes of data. Well, GPT-4 was trained on roughly 13 trillion tokens of data. So we've gone from having a large to an unimaginably large corpus of data. So I'm sorry, I just saw somebody, you guys are seeing my slides, right? I saw somebody in the chat, or do you just mean share them afterwards? I'm sorry to interrupt, but it would actually be really hard to follow.
I think they mean share them afterwards. I'll go ahead and monitor the chat for you, Kevin. So and I'll take care of the chat while you continue speaking.
No worries, Robin. That one just caught my attention because if you guys couldn't see my slides, that would. Of course, I will slide the. I'll share the slides afterwards. But so anyway, the point is these networks have gotten massively large. And another thing I like to point out that people may not recognize, they're incredibly expensive to train and operate. So the estimates are that it costs between $10 and $15 million to train ChatGPT, the original version. And that took, I think, somewhere on the order of about 2,000 graphic processing units, 2,000 computer processing units, about 2 weeks to train. This network, we talk about exponential growth in the size of the network, also exponential growth in the intensiveness of the training for that. So $10 to $15 million, 2 weeks, 2,000 GPUs. GPT-4 took 25,000 graphic processing units working continuously for 90 to 100 days. And it's multimodal, so it can process pictures. But just an incredible growth in the technology over the past year. I will say that when ChatGPT originally was released, they were well into working on GPT-4, but still the progress that they made in the past year is really pretty staggering, frankly. And by all early accounts, Google's technology is arguably in some ways more proficient than OpenAI's, and probably has in many ways similar characteristics in terms of the size or cost to operate it. All right, so what are the limits of the technology? Well, it's a difficult question to answer because one of the things that we need to understand is, how is the original ChatGPT different than GPT-4? Well, in OpenAI's own words, this is the limitations are from the Open ChatGPT page, right? And this is for the original ChatGPT. So if you get a free account, you can log on, you can use it. They say that it may occasionally generate incorrect information. This is a real problem. They call them hallucinations. I will tell you that we have had some cases of students using the technology to write papers or produce content that have produced what we call honor cases, right? Like cases where they violated the or are suspected of having. I don't think any of these cases have been resolved. But in many cases, what tips off the instructor is one of two things. It's either a change in tone, so they don't produce the whole paper, they only produce part of it, or it's a hallucination. Like you'll get something where it will quote Shakespeare as saying something that, one of our English instructors is like, well, Shakespeare never said that, Shakespeare said, man, I'd really like some Sunny D. Like, Shakespeare never said that in any of his plays. So it will really make things up. And part of the reason for that is because, like I said, it's modeling language. It doesn't actually have a model of the world that it's working off of in the same way that we do. So it's really looking in corpus of text, and it's going to, in cases, it's going to engage in this hallucination. Now, I don't think that's a problem. It's based on the mathematics of the transformer. I don't think it's a problem that you're going to be able to solve by making these networks larger. And I will say that GPT-4 still has that problem. So that network is much larger. It still has major issues with hallucination. Both networks, no world model. They have no sense of moral value, aside from the filtering that's done on the backside by human beings. So GPT-4 and GPT-3.5 both produce amoral content. They're dependent upon their user to filter the content to some extent or another. Now, limited online learning, because GPT-4 includes the ability to do online queries, this is to some extent mitigated with the newer version of the network. But really, the limited online learning, GPT-3.5, you go on to OpenAI and you start working with the ChatGPT, really, whatever data it was trained on, so you pull that information from the internet at a point in time, if you ask it about something that happened afterwards, it's going to be limited, if not completely incapable of saying anything about it, because its world is really indexed to the point in time that the training data was pulled from the internet to train the language model. I will say, and I just think this is really interesting. It's a problem, but I just think it's really fascinating. Given the scale of the network and the complexity of the network, GPT-4 has actually developed a problem that did not seem to be a massive problem for GPT-3.5, and that is catastrophic forgetting. So you train it on these 13 trillion tokens of data, and it appears at times that the network will completely lose track mathematically of data that it's already processed. So, I mean, I suppose we do this too, but it's not really clear why or when it happens. but there's a sense in which the network is actually losing track of some of the data that it was trained on. And this has caused issues for researchers as they work with these networks. All right, so I want to wrap up real quickly. I've talked a lot about like what's been happening in the field and kind of tried to give you an overview of the technology. So I want to leave you with some tips for using generative AI. I think I'm going to give you four tips, and then we're gonna look at a different approach to thinking about this very quickly. So I think the first thing that I would recommend to you is you need to think small. I think one of the challenges of using these AI systems, and you can see it in public reporting on these AI systems, is you need to avoid anthropomorphizing the technology. The technology understands the world, it cognizes very differently than human beings, which means that it's going to do things well that we don't do well, and it's going to do things poorly that we do very well. And so I think instead of thinking about it in terms of, hey, this AI is going to replace human beings, like, I mean, we are at a step in the technology where the AI, generative AI, can be an incredibly useful tool. I've heard people say, you know, kind of like the dean in the slide earlier on, like it's like having a really well-educated colleague. I think it's best to think of them as tools and not colleagues, right? You don't want to engage in open-ended conversation with it. Think about your goal in using the AI, and it should be in generating some artifact. It should be generating some piece of text or generating some piece of media, audio file, video file, and think about the AI as a way of helping to realize some idea that you have, whether it's in writing or in media. Second, build proficiency. You have to play with this stuff if it's going to be useful for you. Effective AI use is skillful. You'll hear people talk about prompt engineering. If you don't know how to ask or how to prompt the AI to produce the thing that you wanted to produce, and you don't know how to query it and challenge it to get it to revise the product it already produced, you're not going to be effective at generating the thing that you're looking for, right? So the old saying, computer science is garbage in, garbage out, that's still very much true for generative AI. So in a sense, no different than using any other technology, whether you use an Android or an iPhone, learning to use that technology is an investment of time and resources. So if you're playing with OpenAI's ChatGPT, if you're playing with Google's Gemini when it is made publicly available, just realize that you're getting proficient using a specific tool, and those skills may or may not generalize to other technologies. So you have to be willing to invest in building proficiency. Third, content, not creativity. And I kind of already alluded to this, but it's not that AI can't be creative, but it can't be creative unless you're skillful. If you ask it to produce a strategy for dealing with some real world problem, it is likely going to pull from documents that are already written that are doing similar things. It's going to recreate those patterns. Now, if you're clever in building prompts around your own ideas, it can certainly help you to articulate a strategy that has the characteristics of creativity. But I think if you're expecting the generative AI to just produce some creative output, then we might not be properly understanding what the AI does well and what it doesn't. So I always like to think about this in how do you build good teams? Well, you take people that have certain skills and you pair them with people that have other skills. I think if you think about generative AI in the same way, like it's a tool that can do certain things well, but that's about producing content and doing it efficiently, not about creativity. I actually worked with briefly with an entrepreneur who he talks about, think of AI as a bicycle. Like if you don't know how to ride it, it's not going to get you anywhere. But even if you do, even if you know how to use it, even if you're skillful, it's probably not going to get you exactly where you want to go. You're going to have to know how to maneuver the bike, get off the bike, and finish the walk yourself. So he thinks the way he described it was, he said, if you know what you're doing, AI can help you get to an 80% solution, and it can save you a lot of time. But if you needed to get you to 100%, the AI is just not going to do that for you. And then the last thing, iterate and reiterate. So what do I mean by that? Well, first of all, if you know what you're trying to get the AI to produce, then you're going to need to iterate, prompt it, challenge it, query it again. and understand that these models are not fully determined. They're not fully deterministic. If you ask it the same prompt twice, it's very likely to give you 2 different answers. So you can use that early on to help brainstorming. You can generate ideas. How are people thinking about this problem? Figure out where you want to go within that brainstorming, and then prompt it again with, again, working from big to small towards something that can actually help in production. So try again, iterate, reiterate. It's not, I'm going to type in something, it's going to give me a fully formed product. Think of this as a tool that you can work with interactively to produce something efficiently and through your own creativity that can be incredibly effective at a relatively low cost in your own time and investment of resources. But I think creatively, you're going to have to do the work. So with that in mind, I want to finish with one slide. I literally did this morning. I got out of bed, I poured a cup of coffee, and I said, I spent all this time thinking about, like, what are the tips that I have for people in terms of how to use this technology well? Like, why don't I ask ChatGPT what it thinks good tips are for using generative AI. So the prompt was, what tips do you have for using generative AI? And I'll just leave this on the screen for a moment, let you read them. I don't know if I wasted all the time putting that together, because and there's certainly more to say about that, but that's a pretty good starting point for the presentation that I put together, and it probably would have saved me some time had I started there instead of thought of it this morning. So anyway, I found that amusing. I thought I'd share it with you guys. So I think I am a little over, Robin. I apologize for that, but I welcome your questions and thank you for your attention.
Thanks, Kevin. That was incredible. We do have questions in the chat. I'll go ahead and start with them, and we'll get through as many as we can. Matthew asks, every other period of advanced